Welcome to our talk. So the title it's Adobe and SAP, all your business documents belong to us. Or yeah, what can go wrong? Just to maybe the best way to show you the purpose of this talk is to show you the first demo. So this is an SAP user, a normal user. You just choose a SAP system. Let's say this is a HR end user. He just add a new employee, so he put the name, etc. So this just manage the table, and click on print version to have basically a PDF. So it just generate a PDF like that. All right. Okay. Of course, behind the scenes, something happened. So just imagine that the user continued to work on it. For example, you just change the city, and you click again on print version. Something happened. Oops, we have a pop-up like, hey, hello, GreHack, okay. And also, you can see there are annotated picture attached to the PDF. And as well, the value itself inside the PDF has changed. Now the salary, it's quite okay. So basically, this talk is what's happened behind the scene, and what is also important to take care about what we will show and how to protect it. So my name is Yvan Genuer. I work on SAP since 22 years now, I guess. The last 12 years only on security on SAP. I found many vulnerabilities. I work for Onapsis as a security researcher. And today I will present also with Fabian. So please welcome Fabian also.
Hi, everyone. Thank you. So glad. Thanks. So my name is Fabian. I'm also working as a security researcher with a focus on enterprise applications and specifically SAP software systems. And yes, basically for me, this is the first time at this conference, so I'm really happy to be here today and share the stage with Yvan. Today we will take you on our journey into the world of SAP and business document creation. For those not aware or not fully aware of what or who is SAP, it's a very large software vendor producing solutions for companies to manage business critical processes. And one of such processes is also handling the creation of PDF files and documents, of course, and this is what we're going to look at today. So when we started to see what technologies are available for SAP users to generate business documents, we found those three you can see here on the slide. So basically the one on the left, SAP Script, and the one in the middle, Smart Forms, are rather old solutions that are closely tied to SAP's core platform technologies. But the subject for today, the target we had during this research, is the one on the right-hand slide. That's Adobe Document Services, or short ADS. And ADS is a joint solution by Adobe and SAP. And the version of ADS we looked at during this research is basically an on-premise extension customers can install in their SAP system landscape to manage the process of electronic documents creation, but also interactive forms, for example. And there were a few characteristics of this solution which made it really attractive for selecting it as a research target. The first one is basically what you can see here on this slide, which is a common deployment module to install that solution in your system landscape. So basically, you have a central SAP system, which is typically SAP's NetWeaver application server Java. That is a runtime environment for operating Java applications. And this is where you install ADS on top of it. And then you have all your other SAP systems in your landscape. So for example, an enterprise resource planning system, but there are also various other kinds of SAP software solutions. You have all of them connected to that central instance. So when they have the need to create a PDF, let's say, they will send this request to the central ADS solution. Now for us, this also meant when we look at this architecture, of course, ADS could also be a single point of failure, right? So again, it made it really interesting to take a look at it. So we started to see what previous research has been done. And maybe you noticed 2 slides ago, we put there that ADS is the most recent solution, and it is actually still the most recent solution, but it's also already quite old. So we found vulnerabilities dating back to 2010. But overall, we didn't really find a lot of things. And as you can see, all of the vulnerabilities were also rather old. And when we look closer into them, it was also like that most of these issues are not directly impacting ADS, but dependencies ADS is relying on. So again, we came up with, or we concluded that it might make sense to do our own analysis of this component. And this is basically what Yvan will now kick off with our first finding.
Yeah, thank you. So now we, for many reasons, for what Fabian said, we decided to start on, let's say, to do some research on this ADS. So we installed the ADS in a whole lab, and we tried to do something. So this is where we get the first finding, and we call it the XFA breakout. So you recognize this is the same application from the opening demo. So it's the way we can use to print PDF on SAP system. So we just make a few tests, like, okay, how I can print PDF, what has pun, and we just sniff quickly the network just to let know, okay, by curiosity, if we can see something or something. And very quickly, we found something like that. So normally, so in this diagram, you can, on the top left, this is the SAP system, and on the right, this is another SAP system, but with the ADS component, okay? We will use this diagram a lot. So what we discover is if we try to print a PDF from the SAP system, so the researcher is connected to the SAP system discussed with this web services, the WSILV PDF, and then the PDF is generated. What we discover is, okay, we can communicate directly with this web services without authentication. Okay, cool. So we sniff a little of what's it's in size, what these services accept. And it looks like it accepts some data in XML format, and then let's say they parse this data to create what we call an XFA. And this XFA, it's how the Adobe document services will generate the PDF. So what is XFA? It's meant for XML form architecture, so it's come from Adobe. And it's quite old. I will not go into detail. If you want, we put the references. I think it's like 1,000 pages document. So basically, in the XFA, you can it's an XML format, and you can precise. Okay, I want this data in my PDF. I want this PDF with this format. I would like this font, etc., etc. So this is where you can specify everything in the PDF. So we read the part of the documentation, and very quickly we spot that, there are a script tag in this XFA. So we can also, in the XFA, you can execute JavaScript, also form calc script, but it's basically the same things. So the first findings, so just imagine that we are on the first day, and we find that in the data we send to the web services, we find an injection where we can inject any XFA command. So what command we add? We add a script. So, and in this case, we add a script. And what is interesting is that you can precise when or where the script is executed, on the client side or at the server. So in this case, in this injection, what we do is just we have a JavaScript when we try to get the version, the hostname, etc. If we send that, we receive a PDF with the version, the hostname, and everything right in the PDF. So from that, we try to leverage from this access. We try to do a lot of things at this time, but we never, let's say, successfully find a very good exploitation. But it was the first finding very quickly. So this is where we say, okay, now we should go a little bit deeper, and also, until now, we don't exactly understand how it works. So, okay, we are connected on the SAP system. We understand that they use a user normally to discuss with Adobe Document Services also directly. But in the middle, this is like black magic for us. So what we did, we just, of course, we are in our lab, and we try to trace everything, sniff everything. So we just issue this kind of script. The goal is, okay, to have a traces of what we do. So we launch it, and we try to print PDF, we try to inject in the XFA injection, etc., etc. So basically, we try to do some activities, and then to see what we have. So we get a lot of information, and this is just to summarize. So first things, yes, it's complicated. So for us, again, it's another signal. So, it is complicated. It could be a good sign for bug hunting. So we try to simplify a little. We not go into detail again. So basically, how it works. So and so the user on the SAP system communicate with the Adobe Document Services. The Adobe Document Services, when he wants to generate a PDF, he just launch XML form.exe. This is a bash script, even with this extension. And then this bash script executes this binary, the XML form. The XML form is where, for example, the JavaScript injection, this is where it's really executed. So the XML form generates the PDF itself. Then he writes somewhere in the file, in the temporary file, he writes the PDF somewhere to provide it to the services. And most interesting parts, or one of the most, well, this one. Who knows what is IIOP protocol? We guess. No one knows. We discovered that it used this protocol, IIOP protocol, to communicate between the Adobe Document Services and the XML form. So no one knows what is it, even us. So we do our work and we try to understand what is it. And Fabian will help you to understand.
All right. Yes. So this protocol or that communication going on there definitely stood out because of multiple reasons, as Yvan mentioned, and it was also something unusual. And when it's something unusual, then it's probably interesting. So we try to better understand what this protocol is all about. So we searched for it, and it turns out that this is basically the TCP/IP implementation of a more abstract protocol that is defined in a standard called CORBA. And CORBA describes an architecture where distributed systems that could be possibly written in different programming languages can communicate with each other and exchange object information. So what you can see here on the right-hand side is a really basic view on this from the public specifications of the standard. And most importantly, in the middle, you have what is called the ORB, which is the Object Request Broker. And this component of the architecture takes on critical tasks like handling the communication between the client and the object interface, but also maintaining references to the registered objects. And for such an ORB to speak with another ORB, that is basically where the inter-ORB protocol comes into play, so IIOP. And when we now look at our scenario here, we basically have inside SAP's Java application server a service or a binary called the ICM. And that one handles most of the the task of handling all kinds of communications, both outbound and inbound. And one of the services it provides is the IIOP service. So basically, Java applications running in the Java environment can use the IIOP protocol to speak with other external services, but they can also receive IIOP requests. We then try to better understand where most parts of the CORBA standard are being implemented in SAP's application server, and these are basically the packages that we found. And then finally, of course, we had that binary, which seems specific to ADS, which was speaking through the ICM to the Java backend in both directions. So digging a little bit deeper and trying to understand how this communication is initiated, this is what we found at the very beginning. So in our traces, as we noticed that, or at the point where the XML form binary is being executed, we saw that this huge hex data was passed as an argument. And this data, what you can see here, is actually a specific data structure which is defined in the Corba standard. So here you have a hex stamp. And that interoperable object reference, which is the name of this hex data, provides an ORB client, let's say, with sufficient information to execute an operation or access an interface of a remote object. And as you can see here, we have information like an identifier, let's say. So here we see that probably the XML form binary tries to make use of an interface that is called the COM Adobe Service Manager interface. Then we have the information where we have to direct requests to access that interface. So this is basically the ADS host name and the service port for the ICM IOP service. And then finally, we have what is called an object key. And this object key looked a bit random, and we didn't really understand how it is constructed here. So we tried to see if we can pinpoint the piece of code which generates that key. Because from the standard, we understood that we have to know this key to access a specific object. So in this case, the Corba manager object. So facing that challenge, we did a little code review, and inside the Java packages I've just pointed to. And this code snippet you see here is basically responsible for generating the key. And overall, the key consists of 3 components. So first of all, we have a server ID, which is a static component. It's always the same for that server instance for all objects. And then we have what we call the object counter, which is an incremental value. And finally, we also do have a timestamp here. It's also a timestamp in milliseconds. So here you can see a simple packet being sent from the XML form binary to that service to access a specific operation. And as you can see here highlighted with colors, that's basically the object key being used. And what else we noticed here is the fact that there isn't any other kind of logon material. There isn't any other kind of authentication mechanism in place. So we thought it could be interesting if we can somehow obtain that key. We could inject ourselves into this inter-process communication here. So the next step was to see how we can actually speak with that service and what options we have to get access to that key. And the first thing we did was creating a little test application, the one you can see here. We call it IOP Chat. And it's basically what you can find in Oracle's reference implementation to speak with what is called the name service. The name service here at the bottom is a service which is also named in the Corba standard, and that service allows access to a tree-like structure where you have all the Corba objects registered. So our idea was maybe we can just get a reference to that service and ask it for that key that we are looking for. So executing that script remotely, we faced another challenge. It just didn't work, and the communication got interrupted like immediately. And there was no option for us to access that name service. So we tried to understand what is going on here. And turns out that this was actually rooted in a patch SAP introduced to a previous vulnerability that was reported by Yvan actually several years ago, which was a server-side regress forgery in the IOP service. And to patch that vulnerability, SAP introduced a specific allow list that now restricted who can access that service. So that's was basically the root cause why the communication got interrupted. And now, of course, we wanted to see where this is actually implemented and if we can bypass it. And what you can see here is basically the very early processing of the IOP packets. And we figured out that there is a certain section inside the packets where you can define or add what is called a service context. And if there is a service context with a specific ID, in this case it's ID number 6, then we notice, okay, we will enter that method which enforces those allow lists. So in our packets that were generated by our little IOP chat testing application, we found that service context being included. Now, looking at the standard again to understand what this context is about, it turns out that this is something, without going into the details, which seems to provide a way where you can add hidden parameters that allow the receiving ORB to have more information about the data that is passed in the request. We thought, okay, maybe we just don't need that in our case, so why don't we just switch that byte? Or simply remove this service, and actually that worked. So a very simple bypass, and we got access to the service, and now we had a reference and to that naming service, and we were able to execute specific standard operations to ask for object keys. But we weren't able to find that key that we were actually looking for. You remember the Corba manager object key? We weren't able to get it. So we had to look for a different way, but at least now we were able to communicate remotely. So if we cannot simply ask for that key, the next option was to see if we can brute force it.
Yeah. When we speak of a brute force, we always call me. Okay, so this is the key we would like to get. So again, quickly, so in green, this is the server ID, followed by what we call object counter in blue, and then the timestamp in yellow. First of all, the server ID. So the server ID, as Fabian mentioned very quickly, so by sending like the very first, the resolve initial name service, we receive in the response, in the packet, we have the server ID. The server ID is unique for the instances, for the host, let's say, okay? So, okay, one request, and we leak this server ID, very easy. Next. The next, it's the object counter. So, the object counter, how we can get this? Again, we try to brute force the object key of the Corba manager object. Okay. So, but what we find is like, okay, we cannot resolve directly and get the key of the manager, but we can resolve. In this context, for example, the Adobe services, it always exists in this system. And if we do that, we receive a packet, and inside the packet, we have an object key. This is not the good one. This is another object key, okay? This is not the one we're looking for. But we have the server ID, and just after, we have the object counter. In this case, this is 57, all right? We analyze quickly where this comes from, so okay, and it comes after the resolve, you get an exception, blah, 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 and on the top right, we have the object counter, where the object counter comes from. And the important thing is this object counter is globally managed by the application. It means if we request a new object key, the next object key will have the counter 58. And the next one, and the next one. So by sending only this simple request, we get the status of the current state, let's say the current value of the counter. How it can help us. So back to this diagram. We send this first request, and now we know, okay, the current counter is 57. This is where the XFA injection comes back. This is what we find. If we send an injection, so XFA injection, remember to generate a very big, to generate a PDF. If we inject this kind of very long process, the XML form just run, okay, in the background. And if during this time we send a new request, hey, I would like to generate a new PDF. Okay, because the first one it's still processing. The Adobe Document Services spawn a new one, a new XML form appear in the process list. And you guess it, new XML form means a new manager object key, the key we would like to brute force. So we do quickly test, and we figure out that, okay, if we do that, like create a long, force the XML to spawn again, the object key counter, the object counter is always +3. So in this case, we just send one request to get the object counter, and we know if we force the XML force to spawn again, the object counter will be 5.8. We do not need to brute force it. That's very important. Okay, so we get the object counter. Now, speak about the timestamp. They use the timestamp. This is a timestamp where the XML form, when the XML form is launched, they use the timestamp to generate to put it in the key. So again, how we can brute force it? Of course, it's complicated to brute force the whole timestamps. It could be very, very long. But again, we will use the same tricks to send a very long XFA injection. So we will force the XML form to run in the background. And in the second request, instead of sending a normal one, we inject again. But this time, we ask for the date. So what's happened? A new XML form is created, a new object key is generated, and by sending that, we receive a PDF, and inside the PDF, we have the timestamp of the PDF creation. So we can compare when we launch the first request, so this is the timestamps on the top left, and between the timestamps we receive in the PDF. In this case, this is like few seconds, so 4 seconds. 4 seconds is like few thousand, 4,000 requests, so this is nothing. We can start brute force all these few thousand requests, and very quickly we guess the timestamp like that. So we have, now we have everything. So what we can do with that? This is the next one.
All right, so we finally got that key, and now comes actually the interesting part. What can we do with that key? And today we want to show you two kind of attacks. The first one actually brings us back to the Open the Demo video, and it's about an IOR injection. So what we did after obtaining that key was analyzing what methods that Core Manager object interface exposes. And the first interesting method we saw was called register controller. And that's basically a method being used during startup of ADS, and it's used by the XML form to register at the Java ORB site to say, hey, I'm the XML form, I'm here. If you have any requests for PDF generation, you can send it to this localhost port here in this case, or the external interface of the ADS host on that specific port. Now, since we have that key, we can make use of this method on our own and inject an IOR. So what does this mean? It basically means we can say, no, the XML form binary is not located here on your local host system. It's basically here on our attacker machine at this port. And thereby we enter like a man in the middle position where we can now basically receive all the data that is intended for the legitimate XML form binary. And we receive that as an attacker, and we can also tamper with the data and respond with whatever we want. So this brings us back to the demo video we have seen at the very beginning. And now we have both sides. We have the attacker point of view on the right-hand side, and on the left, that's the victim. So first we have the victim using the test application in this case as usual. So just to confirm that everything works as expected. And then on the upper right terminal, we basically have the attacker executing the brute force attack we discussed. So this will be very quick in this case. So as you can see, we get the current value of the object counter, the static server ID, and then we will brute force the timestamp, and then finally we got the object key of the new Core Manager object. And on the bottom, we start our rogue XML form ORB, and we now execute the IOR injection through the register controller operation to say, here, this is our rogue ORB model, and as you can see, we receive the connection. So now what happens next if the user tries to generate a new PDF? As you see, we going to receive the request in this case, and we respond with a tempered PDF. And of course, besides tampering with the data, as I've mentioned, the attacker can, of course, also look into the data that has been initially sent from the client to the ADS solution. So here we see all the data which is actually included in that PDF file. Oh, and yeah, and I always forgot about that slide, but yeah, of course. So what does this mean now when we look at the overall picture again? This basically means that any SAP system connected to that central ADS solution is basically affected by this issue and this exploit, because we can tamper with all the business documents that are being generated or that are about to be generated by the legitimate ADS instance.
So what we demonstrated is with this kind of vulnerability, we can attack the client, basically, but also we find different vulnerability on ADS, and we have also something to provide, like how to attack the ADS itself. So very, very quickly, when you configure a new SAP system and you want this SAP system to work with the ADS, you need to configure some credentials. So the name by default is ADS user. So it means all this SAP system use this ADS user to connect with the ADS system. So just imagine it in a scenario you already compromise one system, or you guess, or you find the user credential. It's not so complicated. So if you have this credential, we find a way to execute also, to have a remote command execution of the system. So, few things. The first thing is we find a way to, instead of, when we request for generate a PDF, we find a way to, instead of receive the PDF, we can store the PDF on the server side. So that's cool. And of course, we also find another vulnerability to store on any place. So what we are able to do is to, let's say, upload any kind of PDF, only PDF file, and we can overwrite any kind of file. So what we will overwrite is the XML form itself. So the binary in charge to generate the PDF. So, okay, we are able to overwrite this file with a PDF file. So what we do, we craft a very particular payload, and this payload, when it goes to the XFA, to the Adobe Document Services to be generated, at the end it will create what we call a polymorph PDF. So it is a PDF, a normal PDF, but if you execute it, it's a bash script. So this is what we call polymorph PDF. So thank you to Corcan. So now you guess it. Again, what we do, we force the first XML form, the current XML form, to run in the background with a very long injection. And when we send a second request, normally, a new XML form is spawned. And of course, we override this new XML form with our polymorph PDF. So now we get remote command execution like that. Yeah. So on the top in green, this is just a loop, a file in the XML form. So as you can see, the XML form, it's a bash script, even with the extension. On the bottom right, this is the listener, and on the bottom left, this is the attacker point of view. And on the bottom left, I just execute the exploit. First exploit, I will overwrite the file, so the file changed. Now it's a PDF, and then we send the long XML stuff, and then we force the XML form to spawn again, and we get remote command execution like that. Of course, we will provide how to protect and what it's important to know about it.
All right, so we reported all of the findings we have shown you today to the responsible development teams through SAP's product security response team. And So SAP basically released a set of patches. The ones you can see here on the slide basically address all the issues we found in the web services. So we have the XFA or XML injection, but also the authenticated the text. There are some more patches here for other issues we hadn't the time today to talk about, but those were basically the patches SAP released already last year to address these issues. And then for the brute force part, mainly for the IOP part, SAP also referred us to a specific note, the one you can see here on the slide, about the IOP SSL, because IOP SSL is like a secure version using SSL on top of the IOP protocol. And it's not enabled by default, but there is this note saying how you can basically enable IOP SSL, how you can disable the plain IOP port, and also most importantly, how you can enforce client-side certificates. Because what does this mean? So as I said, the patches protect against the findings we run against the web services. And then with client-side certificates on the IOP service, we finally have authentication. So the brute force attack we executed is basically not possible anymore. So lately, like just a couple of months ago, I think it was during the September Patch Tuesday of SAP, there were 2 new additional patches being released. The first one is about an outdated OpenSSL version. This one was not found by us, it was found by someone else. We tried to obtain the name of the researcher or the person that reported this, but we weren't able, unfortunately. So the second one is based on our submissions, and it addresses the generation of those object keys specifically. So as you can see here, now how the object key is generated has changed. Now we do have a pseudo-random number generator being used that basically replaces the timestamp and object counterpart inside those object keys. So this brings us to our final slide, our conclusion. So we hope we were able to give you some insights into what turned out to be a very critical component in SAP system landscapes. We hope we were able to show you a bit about SAP's custom implementation of the CORBER standard, and how we were basically able to leverage a vulnerability with the XML or XFA injection that at first glance looked limited, how we were able to escalate that to a very critical chain, let's say, to get that object key and finally enter this man-in-the-middle position. When it comes to future work, so what we looked at today was the on-prem version of ADS. There is also a cloud solution, which is called SAP Form Service by Adobe, and it runs in SAP's so-called business technology platform. We haven't looked into this. And then there is also plans for a new ADS version that is not being operated on the Java application server, but instead on what is called the HANA HANA Extended Application Services, which runs on top of SAP's HANA in-memory database. Also something, of course, we haven't now the time or a way to look at, because I think it's not even released yet. So those might be targets for the future. And then, of course, our call for action, if you run one of those things we showed you today, so basically if you operate ADS, then you should patch these findings, because I hope we were able to make clear that's a very critical component. And also, you should enforce IOP SSL, because it's not enabled by default. And with that being said, here are our references, and that's basically it. Thank you for your attention.
Thanks a lot, Yvan and Fabian. Does anyone have a question? You are not SAP fans? Oh, yeah.
Oh, sorry.
Hey, nice talks. Thanks a lot. How long did it take for SAP to patch the vulnerability? So once you submit the issue, how long did it take to fix it?
I'm not sure, but we submitted, let's say, in March 2024, and I will say in June or July, everything was patched. We get some few discussion because there are some not issue, but there are some issue yet to reproduce some attack or to fully understand what we do. So there are some delay because of that. But when after they accept, it's come normal, let's say.
Thanks.
Here.
Oh, there's one as well.
It's a race.
Yes. When you do some kind of brute force, like a few thousand attempts, like you did, is it not spotted as a suspicious activity by something or a team or a software somewhere?
We do this brute force over the IIOP protocol. On the port, the default port is 5007 on SAP system. We can say it could be suspicious, but we can also like hide this few thousand because you can send like few hundred time to time. And instead of take like less than 1 minute, the brute force we can take 1 hour, maybe 2 hours, but it's still reliable in real life, more or less. So.
Okay, thank you.
How do you manage to get the product installed to do your research? I mean, it's so complex to get them and to have them running. From my memory, it was the biggest difficulties in SAP research.
Yeah, you mean how we get the Adobe document services components?
I mean, both the software itself and the running installation of it.
Basically, on Apsys, we are partner with SAP, and so on Apsys are able to download or download they buy some licenses with particular price, or maybe it's expensive also, probably. But for us, as a researcher, we just ask, hey, we would like to have that in our lab. It's validated somewhere, and after 1 week we have it. So
easy.
For us, it's like easy, yeah.
Any last question? Okay. So we will have a short break, and the next talk will be at 11 a.m. So you have food if you want, drinks.
Thank you.
Thank you.